Good so far. Just need the last three graphs.
Okay, that's good. Alright, so yeah, you guys got a week till your project is due. So don't forget, you guys have to type out, some write-ups too.
For that write-up portion, we're just explaining what the code is doing, right?
Yeah. Yeah, just look at my example, but yeah, you're just explaining what the code is doing, like you said, yeah.
All right.
Alright. So if you have, again, if you have any questions on the project, just go to office hours today or go in the Discord. Alright, so I uploaded some new data for the project last night. So I know I haven't been doing it every day, but so I uploaded new data, and then if you saw in the Discord, I forgot to update one of my graphs, but I updated that. So if we go down here, I actually updated all of them last night to reflect the most recent data. So if we zoom in here, so yeah, if we zoom in, then you can see that all of them are updated to the latest data, which was November 1st. So you can check that out. And let's see. So I think it was figure 10 that was incorrect before. So for some of these graphs, a while back, I made them per 1 million. I sent out an email about that. I think it was like, I don't know, a week ago or something. But I forgot to update one of this graph here to actually reflect that as per 1 million. So now it's updated to per 1 million. So your graph, it should look like this. So it's new COVID-19 cases per day by a 7-day average per 1 million people for the most populous California counties. So you should have numbers that kind of look similar to this. So you'll see, in July to August that this is when there is a big spike. And your number should be, somewhere around here. We see like San Bernardino, they were around like 350. So your number should be similar to this. Okay. All right, so yeah, check that out. And yeah, I guess that's it. So today we're going to go over for looping. So I actually have data for that as well for an example that we're going to do in class today. It's actually this same data here. So it's same data as the video that I posted. I don't even remember when I posted that. I think it was like on last Thursday or something. For auto, there's a video for automating your code for plotting with MATLAB. So if you didn't download this data yet, you should get that. It's postseason data. You can either get the data from this link here for the first project, or if you're on the home page, you can go to today's week, so week 11, and then I uploaded the data right here. So it's postseason example data 1 and postseason example data 2. So you have to get both of those. And one more announcement before we get started. So we're going to have a short quiz this Wednesday. So we haven't had too many quizzes in this class like I was planning on. So I'm going to try to increase the amount of quizzes that we have, just so we have a better spread. But what I'll do instead is have shorter quizzes, more often. So we'll have a short quiz this Wednesday. It's only going to be one question. I'll give you 15 minutes though, so you'll still have a lot of time. And it'll be on if statements. So what we went over last class. I think 2 classes now. So make sure you just go over the slides that we had. I don't have any homework assigned yet. I'll probably assign that once we're done with for loops. But yeah, just make sure you go over the slides, and we're going to do another example problem today for if statements to kind of, for a review and also to prepare you for the quiz on Wednesday. All right, I also updated the slides too, so they're on Canvas. That's the project. if you didn't do this part yet, it's not really a spoiler, it's just importing stuff. Okay. Let me open up this week stuff. Okay, here we go. Sorry, I didn't get everything, all set up before class because I was letting my dog outside. It took a while. Alright, so we're going to do this example right here. So it's just a review exercise for if statements. Again, this is going to help you prepare for the quiz this Wednesday. So here's what we want to do. We want to make some input variable grade. So I'm going to go over this part with you. Okay, so I'm in a script right now. Let's do clear and then CLC. Make a section. If statement example or exercise. Okay, so we're going to make some variable called grade, and then we'll set that equal to, 80. And we can change this later on, but basically I want to make some input variable that's called grade and assign whatever number you want to assign to it. And then you're going to use if statements and maybe else and else if. And basically what we're going to do is, so you're going to have your input variable called grade, and then you're going to write some code that's going to display one of the following statements depending on what number was inputted for your variable called grade. So if the grade is greater than or equal to 90, then we're going to display well done, chap. If it's greater than or equal to 80, but less than 90, we're going to say pretty good job. If it's greater than or equal to 70, but less than, 90 and 80, we're going to say could have done better, mate. If it's greater than or equal to 60, but less than 70, we're going to say, in the words of Walter White, apply yourself. And if it's less than 60, we're going to say, we need to talk. So from last class, we talked about how to, use the display command. So that's just disp, and then in parentheses, and then apostrophes, you're going to put whatever you want to display. So really simple command. Okay, so let's go back, and then I'll give you a few minutes to work on this. I'll make this a bit bigger. And then I'll put in the command window the display command just to kind of refresh yourself. Well done, chap. Yeah, you could probably use the fprint command too. I never used that, but that might work too. Okay, I'm gonna give you, 3 minutes to work on this. All right, I'm going to give you about 1 more minute. All right, so let's go over it. Hopefully you at least did most of it. Let's make this smaller again. Okay, so in my example in the slides here, I put grade equals 90. Doesn't matter though. So this is the code here. So you can maybe do it in a different way as well, but this is how I did it. So we have if grade is greater than or equal to 90, then we're going to display well done chap. So display and then well done chap. And then we're going to use else if grade is greater than or equal to 80. Then we're going to display pretty good job. Okay, so we're going to display pretty good job if we are greater than or equal to 80. But since we already specified if a grade is greater than or equal to 90, we're going to display well done chap. We're only going to display pretty good job if we are, again, greater than or equal to 80, but also less than 90, because we already specified an argument for if we were greater than or equal to 90. And then we can use that same kind of logic for the other grades. So else if grade greater than or equal to 70, display could have done better, mate. And then else if grade greater than or equal to 60, display in the words of Walter White, apply yourself. Kind of harsh. And then the last thing we're going to do is else. So we already covered grades that were from 60% all the way up to basically, 100%. So if there's anything that's below 60%, we're just going to display one command. So, or we're going to display, one sentence. So if any grade is less than 60, we're going to use our else command and then display we need to talk. So ominous. And then we're going to end it. All right, so there's the code. So if I run this now and I have a grade of 80, then I should see in the command window here, pretty good job. So let's run this. I'm going to have to save this file. And yep, it's the second. So classic examples, 1102. And then we see in the command window, pretty good job. So again, we see that because I have a grade of 80, that's greater than or equal to 80, so we see pretty good job. Let's try out 83. It should be the same thing. We should see pretty good job. We do. If I make it 95, then we should see well done, chap. And we do. Let's do 55. So that was less than 60, so we see we need to talk. Let's do 65. In the words of Walter White, apply yourself. So here we were greater than or equal to 60, but we were less than 70. So then we see in the words of Walter White, apply yourself. Okay, any questions on this exercise? Okay, it's a relatively simple exercise, and your quiz, I'm not going to make it, too hard or anything like that, but I'm not going to make it super easy either. It'll be, somewhere kind of in between. So this example here, your quiz will probably be a little harder than this, but not too much. Okay, no questions? Okay, so we're going to do a quick preview of for looping. We kind of did a preview last class as well, but there's be some good motivation for what we're going to talk about today. Okay, there's a question in the chat. What's the difference between else if and else then if? Well, it depends on how it was formatted, but here we're using else if to display just some other argument. And then I have else at the very end here because I'm just saying to talk about or to cover basically any other value that we have for grade. So when I say else if, I'm actually specifying some other grade here. But else is just going to cover any other grade at all that we have. So there's another question. Will the quiz just be on programming? Yes, it's only going to be, even specifically, it'll be on the if statement. So that's, if, else if, and else. It'll be on just that. Okay, so let's go over a quick preview again for looping. So far for our variable grade, we only had one number here. It's only a scalar. So let's make it a vector. So I'm going to have basically a list of grades. And then we can see multiple statements that'll show up in our command window at once that correspond to each grade that we input in our variable called grade. So I'm going to do grade equals. I'm just going to make a list again. So we'll do 65, 87, 92, 90, 40, or I guess 33, sure. And we'll do 70 and maybe one more, 72. Okay, so at the very beginning here, I'm going to put our for loop. So this is going to go through our vector here for grade. And it'll go through each value that we have in here. And once it does that, it's going to go through all of this block of code here to determine what kind of grade we have, and then it will display whatever statement that corresponds to the value that we have in our vector. So let's do for I equals 1 to the length of grade. We'll go over this later on, but 1 to the length of grade. And then I'm going to go through our statements here. So there might be a way to actually just tab everything at once. I'm not sure. There's got to be. But I'll do it the slow way. Okay, and then just this one. There we go. And I need to add on one more end statement. So there we go. And I also need to add in grade I. So what I'm doing right now, each statement here is going to run through our vector that we made up top for grade. So it's going to look through each value. But again, we're going to go over this, this kind of method in really just a few slides. Okay, so if I run this now, let's actually first clear this. And then if I run it, then we see a whole lot of statements here. So what it's first doing, it's looking at this first value in our vector grade. It sees that we have a 65% for a grade. So we are going to have, in the words of Walter White, apply yourself. The next one is 87. So that's greater than an 80, but it's less than a 90. So we have pretty good job. And we have a 92 and a 90. So we see two well done chaps. Then we see 33. So we need to talk. And then the last two are greater than or equal to 70. So we have could have done better, mate. Okay, so that's pretty useful. We can have a vector here with a lot of values, and we can use a for loop to go through to loop through each value that we have in our vector for grade. And then we can evaluate that grade and have a statement. All right, so for loops, let's go over this now. So this will be, the main topic for today. All right, so a loop is going to be a structure to repeat a calculation some number of times. So like our example that we just had, we used a for loop here, and we were going through this block of code for every value in our vector for grade. So we were doing the same code, but we were repeating this calculation for each value that we had in grade. Right? So each repetition of a loop, so each time we go through our loop, that's going to be called a pass. Okay, and then MATLAB has two types of what's known as an explicit loop, which is a for loop and a while loop. So today we're going to go over for loops. Either next class or the class after that, we're going to go over while loops. So a for loop, we know the number of passes already ahead of time. So here I had our number of passes that was for I equals 1 to the length of grade. So that's from 1 to the length of our vector here. In this case, the length of our vector is 7 because we have 7 values in our vector for grade. Okay, and then for a while loop, we do not know the passes ahead of time. The looping process is going to terminate when some specified condition is satisfied. So we're going to go over while loops again, either next class or the class after that. Okay, so here's a flow chart. Let's make this full screen again. So this is going to be the typical structure that we have for a for loop. So we have, this is our syntax here. So for index equals m colon s colon n, do some stuff, and then end. So index, that's, you might see this word either called index or you might see called counter. This is our variable that we have right here. So here I used I. That's typically used, but really you can use any variable that you want. So we have for I, again, that's like our counter or our index. For I equals our beginning number m. Then we have s is our step size, and then n, that's going to be our last number. So if we look at our flowchart here, we have, this is our counter k. And so we're going to start out at k equals m, and then our loop is going to determine if k is greater than n. So if our index basically is greater than our end number here, n, then if that's true, we're going to terminate our for loop. So we're done. We went through all of our indices basically from m to n. Now if k is not greater than n, then we're going to run some statements and then we're going to increment our counter by s, by our step size. And then we're going to keep looping through that. So this I think is better kind of shown or explained through examples. So we're going to go through some examples here. Okay, so we have a basic example here. So we'll do basic for loop. Okay, so I'm going to do for I equals 1 to 10. Again, I is our index or our counter. For I equals 1 to 10, x equals I squared. And end. So with this for loop, we're going from I equals 1 to 10. So we're going to have numbers from 1 to 10, and we're going with a step size of 1. And we're going to calculate x equals I squared. So we're going to do, I think I put this down here. So we're going to look at the square for 1. So 1 squared is going to be 1. And 2 squared is 4. 3 squared is 9. We're going to keep going like that for every number from 1 to 10. Okay, so if I run this right now, let's comment all this out. I don't want to see that. So if I run our code and then I type in x in the command window, then I see x equals 100. So at first you might be wondering, why don't we see all of the values? Because we were looping through for I equals 1 to 10, and we were calculating the square for each value from 1 to 10. So that's a valid question why we don't see all of the values in our command window. We only see the last one. Now this is happening because we're basically updating x for each pass that we have. So we're doing, first we have x equals 1 squared, which will be 1. And so MATLAB, it calculated that, but then because we're looping, then we're going to calculate x equals 2 squared, and that's going to be 4. So we just updated or wrote over our variable for x. Okay, so that's why we only see our last value that was calculated, which is x equals 10 squared. X equals 10 squared, that's going to be 100. Or x equals, x equals, 10 squared equals 100. Okay, so let's look at all of the kind of behind the scenes stuff that's going on. So if we don't suppress our line of code here for x equals I squared, then we're going to see all of the values show up here in our command window. So I'm going to run this now. And then we see basically every pass that we had for our for loop. So we see x equals 1 squared, that's going to be 1. And then we have 2 squared, 4, 3 squared, 9, 4 squared, 16. You get the idea. Okay, so we see each calculation for each kind of iteration for our for loop. Okay, so any questions so far? All right, I want to make sure you guys get this because for looping is a pretty big deal. It's used quite a lot. Okay, so I'm going to reiterate that while MATLAB did all of this stuff behind the scenes, as our code currently stands, the only value that we have stored is x equals 100, because we were updating or kind of rewriting or overriding our variable for x. So if I look in the command window here, then we see x equals 100. Okay, so sometimes we're going to want to, of course, store all of the values that we have for x. So to do that, I'm going to put x of I. So you saw this in the last example. Okay, so doing x of I, this is then basically specifying the size of our output. So we have for I equals 1 to 10, and then I have x of I equals I squared. So because I have x of I here, this is saying that our output is going to be a variable, or really a vector, that has 10 values. So now if I run this, then you see over here in our workspace that x updated to a row vector that's 1 by 10. So if I double click on that and we look at it in the workspace, then we see all of our values here. We have 1, 4, 9, 16, 25, and all the way through 100. Okay, so now now we're saving every value for each pass that we had in our for loop. Okay, and then again, if I type in x in the command window, then we see all of those values as well. Okay, so using this kind of notation here, where we put our index in parentheses, that will allow us to save all of the values that were calculated with our for loop. Okay, so by default, using this notation, we make a row vector. Now I can make a column vector by doing x of I comma 1. So now this is saying that we're going to have I rows and 1 column, so that it's going to be a column vector. So if I run that and then I type in x in the command window, then there we go, we see that we now have a column vector. Okay, any questions so far?
Yes.
Okay.
Would it be possible to have this create two multi-dimensional arrays?
Yeah, we could do that as well. So we'll talk about that probably later on, not this class, but maybe a future class, just because that's a little more involved. But yeah, we can do that.
Professor, quick question as well. So when we didn't have x sub or x sub I or xi, the code just ran everything from 1 to 10. Of course, it did what you told it to do, but it only saved record of the last number it did.
Mm-hmm.
Okay,
Yeah.
and you put x sub I is when it keeps record of everything it did.
Yeah. So yeah, when we didn't specify x of I, it still calculated the square for each number, but because we didn't specify the size, we just had x equals I squared. We're only telling MATLAB that our variable is a scalar. It's only one value. So because of that, then our output was only one value. In this case, it was the last value that was calculated in our for loop, which was 100. But then if I do x of I, now we specified the size for our row vector to be however many, in this case, columns or values that we have for our counter, which is 1 to 10. So in this case, we have 10 columns. So we're storing the calculation for each pass that we had for our for loop. So I'm going to make this a column vector again. So to do that, I just put a comma 1. So we have I rows, which is 10 rows, and then 1 column. So here is our column vector. You'll see that I have a little red kind of squiggly line under X here. So I can't get the window to stay up there, but it's saying that the variable X, it appears to change size as it's looping, and that we can avoid this if we pre-allocate the size. So we'll probably talk about this also in more depth later on. But basically, as our code currently stands, when we run our code, our vector x is growing in size. So in the first pass, we have a size of 1, just one row and one column. And then as we keep looping through, then we have 2 rows in one column, and then 3 rows in one column, and then 4 rows, and so on. So because it's doing that, it's growing in size, but we can basically save on memory if we pre-allocate the size of our array. So we can do x equals zeros of 10 comma 1. And then you see that red squiggly line, it went away. So this time, I'm already telling MATLAB what the size of my array is going to be, which will be 10 rows and 1 column. So now we're actually not building up this vector because we already have our vector made that's 10 rows and 1 column, but it's all zeros so far. So again, we'll talk about this in more depth later on as well. Okay, but today we're just going over the basics. So we have, again, here just 10 rows and 1 column. That's based off of our index up here. Okay, so in some examples, or in some cases, we don't need to specify the size for our looped variable. So we don't need to specify the size where we have our counter in parentheses. So I'll show you guys an example of when this might be. Now I usually do specify the size because I often actually, I want to see all of the values that I have in my vector or my array. But we don't always have to specify the size for our variable here. Okay, so one example would be when we are doing multiple calculations in one loop, and we only care to save the values for one specific variable. Okay, so I'm just going to add on here another line in our for loop. So we're first going to calculate x equals I squared, and then we're going to calculate y equals x divided by 2. Okay, so imagine for this for loop that we currently have, I don't care to save all of the values of x, but I do want to save all of the values that are going to be calculated for y. Okay, so what this code is going to do, it's going to, again, loop from 1 to 10. And if we take the example for the last loop that we have, or the last pass that we have, we're going to calculate x equals 10 squared, so we're going to have 100. And then we're going onto our new line, which will calculate y equals x divided by 2. So that's doing y equals 100 divided by 2. So our output should be 50. So let's run our code right now, and then I'll go in the command window and type in y, and then we see that our output is 50. And if we type in x, then we'll see, that's 100. So let's say that I want to save all of the values in y. So we're going to use the technique that we just learned. So I'll do y sub I. I run the code, and now if I type in y in that command window, and we see we have 10 columns, and we're saving every value for y, and that was based on the value that was calculated for x. Okay, so even though I'm not saving all the values for x, I can still save all of the values for y if that's what I care about. Okay, any questions on that?
Quick question. If and I know the same thing would apply for y. If you were to put one column, it would give all the results, all the past results in one column, correct?
Yeah, so you're saying if I do y sub I comma 1,
Mhm.
yeah, then we're gonna just have a column vector for y. So yeah, just like that. Okay, there's a question. So why, when we run x equals I squared code, does it only give the answer 100? Okay. Yeah, just like Amr said, x is being overwritten. So MATLAB is calculating x equals 1 squared, 2 squared, 3 squared, and so on. But it's overwriting it because we're looping through. And since I didn't specify the size for x, currently the size for x is only 1. So it's only going to give us that last value that it calculated. But if I do x of I comma 1, then we can also have that as a column vector. I didn't like that. Oh, maybe it's because of y sub I. Let's try that. Nope. I don't know why this isn't working right now. I'll look at this after class, but yeah, because x is being overwritten, then we only had that one value for x. Oh, it's because I need to x of I. Yeah, there we go. Okay, so yeah, this wasn't first working because I didn't specify x of I down here. So I only had one value for x that was saved like this. So if I ran the code, then this didn't work because it only saved our last value, which was 100. And then in this line of code here, I'm telling MATLAB that I want to have 10 values, but it's only able to use one value that was from x. Okay, so that's why I didn't run, but here I'm doing x of I, so now I'm using all of the values that we had in x, and then I can have our 10 values for y. Okay, so we're going to do more complex examples that will hopefully kind of clear this kind of concept up. But if I type in x, then we see that we have our row vector of 10 values, and then if I type in y, Then we have our row vector of 10 values again. Okay, so we talked about this. Okay, and then when we specify our size, we want to be sure that we actually know what kind of size that we want to have. So here, let's change this to a column vector. So if I put in y equals, or y sub I, comma 2, and then I put this in the command window, then we have 2 columns, but this first column that we have is basically useless to us. It's only a column vector of zeros. Now you might have a specific use case where you'd want to do this, but for our example here, this first column vector of zeros, that's useless to us. So we should only put y sub I, comma 1. And then we have our column vector. Okay, so now we're actually going to go through our more kind of involved example. So we're going to be using the data that I talked about in the beginning of class, which is on postseason data for baseball. And we're going to use a for loop here. So this will save us a lot of work than what we'll have to do manually. So we're going over for loops now, and for the project, I don't want you to use for loops. I mentioned this before, but do not use for loops for the project quite yet. I'm not having you use for loops for the project because I want you to kind of do what the for loop is doing yourself, and then later we'll implement for loops. Okay, so let me put the data in this folder. I don't have it in there. Okay, so again, if you don't have the data, it's on Canvas for this week. So it's post underscore 2020 underscore results and post underscore 2020. Do I want you to struggle with what? Oh, for the project? No, it's actually, while for looping, it does save you time for this project. It's not a whole lot of time. But for more complex or like stuff with that are a larger size of data, then for looping would save you time. For us, we're only doing like top 5 countries and top 5 counties. If I was having to do like 100, yeah, then it would save you a lot of time. Okay, so let's do our example here. So here's the plot that we're going to make. So we're going to find which players in the postseason hit a ball over 110 miles per hour and how many times they did this. So just for reference here, the code is going to be 44 lines. Now I'm looking at the time. Hopefully we can finish this today. And with a lot of the examples that we've been doing lately, I tried to structure this example to also kind of help you out with the project. Okay, so I'll make a new script here. And I'll do baseball for loop example. Okay, so the first thing, we're going to do some bookkeeping. So let's do clear CLC. And then we're going to import our data. So I'm going to make a variable called post, and then I'll do equals read table, and post underscore 2020.csv, and then post underscore r equals read table, post 2020 results.csv, not pot, post. Also now, because this is relevant, I'm pretty sure I sent out an email about the video I made for your project that will kind of help you to, in quotes, automate your code so you don't need to manually update things as the day progresses. So make sure you go over that video So essentially, if you write your code, how I kind of go over in the video, as you update your spreadsheets for each new day, all you have to do is just press run on your code again for the new spreadsheets, and that's it. You don't need to manually change anything inside of your code. And what we're going over right now, I kind of touch on some of those techniques as well. All right, so we imported our data. Let's run this. I'll do baseball example. Oops, that's why you want to suppress your lines of code, so it doesn't all show up in the command window. So if I open up one of these tables here, we have one column that's going to be called launch speed. So right here, column 15. And that is the speed of the ball after the player hits it, or right when the player hits it. Okay, so that's the data that we're going to be dealing with today. And then we're going to do a little conversion here. So convert launch speed to double. So if I go back to our table, and I go to launch speed, not this one, this one. Okay, so I can see all of our numbers here. It actually was for this one. It might be really far. There's a lot of stuff here. Okay, yeah, so column 54 for our table called post. You can see all the values here, and that you can see that they're in apostrophes or in quotes. So as it is right now, our type here, or our class, I think it's a cell. So we can find out. So I'm going to type in class of post dot launch speed. And yeah, so our type here is a cell. So later on, we're going to basically have the launch speed that we have in our title for our graph. And we're also going to use a relational operator for exit velocity data. So right now, our type is a cell, and MATLAB can't do a relational operator with a cell. So we have to convert this to a double, or really just an integer. And then we can use our relational operator. So I'm going to do post.launchSpeed equals string to double, and then post.launchSpeed. Okay, so again, this is just going to convert our cell to an integer value. Okay, so I'm gonna go over some of this stuff somewhat fast, just so we can get to the actual for loop part. Okay, so I'm gonna make a little section here, 110 miles per hour plus exit velocity and amount of times. Okay, so now I'm gonna make a variable called launch speed target. And then I'll say target exit velocity equals 110. Okay, so this is the exit velocity that we want to look at for our code here. We want to see when it's 110 or above. And so this kind of technique, right, that I use right now is what I want you, or what you should do for your project, for some stuff that it'll help you save some time. So for example, for some of the plots, we only want to look at, have an X limit starting at the beginning of March. So I can make a variable called, beginning test date. That's not a good one. Maybe just beginning plot date, whatever. And then you can set it equal to whatever date that you want to start your plot at. And then when you call your xlim, you can just reference that variable. So if I do, a starting date of March 1st, then later on I can just do xlim and then start date. And then if I want to change, a lot of my plots at the same time for that X limit, all I have to do is change one value for that variable that I just made. So you'll see this idea later on. So we're going to change this target exit velocity to be something else, and then you'll see that our entire plot is going to change just from changing that one number. Okay, so now I'm going to find the indices when we had an event where we hit the ball 110 miles per hour or above. Okay, so I'm going to do EV underscore 110 indices equals find post. So post, that's our table, dot launch speed is greater than target exit velocity. So if I run this, what did I type wrong? Target exit velo. Okay. So now we have our indices for our table when this is greater than 110 miles per hour. Okay. Okay, and I'm going to make a table. So I'm going to make a table for our indices and our player name. So I'm going to do EV underscore 110 underscore T to, just mean a table. And I'm going to make our table by doing table post dot player name. So this will get all of the player names that we have for those indices that we just had. So for all the indices where some player hit the ball over 110 miles per hour, and then I want to actually put in the launch speed or the actual number for how hard or how fast that they hit the ball. So post dot launch speed, and then we're going to use those indices once again. Okay, and then we'll rename the variable names because right now it's going to be not something that we want. It's just var1 and var2. So let's rename those. So I'm going to do EV underscore 100 underscore T dot properties dot variable names equals, and then we'll do player and then launch speed. And then let's see. Okay, so now we're going to change our player column to a string because it's currently not a string. It might be a cell right now. I forget, but again, I want to go to once we actually implement our for loop here. So string EV110 underscore T dot player. Okay, we're almost to the for loop. So right now, if we go to our table is 41 rows. So we're going to have some repeat names in here because sometimes a player, they hit a ball more than one time for a speed that was greater than 110 miles per hour. So you see this last one, this player, Stanton, hit it 116, and then we also see him right here, and we see him here, and we see him here. So I don't want his name to show up, a lot of times. I want to organize it so I only see his name show up one time so I can call on that when I make my plot. So we're going to use our a function that's called unique. Okay, so I didn't need to put this string right here because I'm doing that kind of conversion again right here. Okay, so I'm going to do find unique players, and we're going to do EV100 underscore players. I'm actually accessing it from, it's from our table. Okay, so string, and we have unique, and then EV underscore 100, 110 underscore T dot player. So now if I run that and I look at what I just made there, then now this length is only 27. And we don't have any repeat names. Okay, so now we're at the for loop here. Okay, now we're actually at the part that we really care about. So I'm going to make a comment here that's find amount of 110 plus exit velocity per player. Okay, so again, some of these players, they hit the ball multiple times over 110 miles per hour. So I want to find the amount of times that they did that. So to do that, I'm going to combine our length function, our find function, and our isMember function. Okay, so this is going to look at our table called EV underscore 100 underscore T. So it's going to look at this table here. And then we're going to look at this column, and we're going to compare this column to this array that we just made here that only contains each unique name. And we're going to find when this column contains one of those unique names, and it will find the amount of times that their name shows up here. The amount of times that their name shows up, that's going to correspond to the amount of times that they hit the ball over 110 miles per hour. Okay, so we're going to use a for loop to do this so we can save time. So I don't want to do it for each player manually by myself. So I'm going to use a for loop. So I'll do for j. Again, for our counter variable, we can use whatever letter we want to use. I can even, do I, it doesn't matter. So I'll do for j equals 1 to the length of EV underscore 110 underscore players. So this is referencing our unique player names here. So my output, I want it to be the length of this because I want to find the amount of times each player hit the ball 110 miles per hour or above. So I want to have some corresponding value for each of these players. So my size should be the same size as this array. Okay, so we have for j equals 1 to the length of that array that we just made. And then I'll do EV underscore 110 underscore players amount. So this will be the amount that each player hit the ball over 110 miles per hour. And then I'm going to iterate on our counter j into comma 1. So the size of this will be j rows and then 1 column. So we're going to have a column vector. And I'm actually going to find the amount of times that they hit the ball over 110. So we're going to do length find isMember EV110 underscore T. So our table dot player and then comma EV110 underscore players for j. Okay, and then we'll do end. And now if I run this, we're going to look at our output that we just had. Okay, and here we go. So now I have a corresponding amount of times that each player hit the ball over 110 miles per hour. Okay, so does this code make sense? Because this is, the main point of this exercise. I'll go over it one more time, and then you can tell me if you have any questions. So we are finding the amount of times that each player hit the ball over 110. So I want to specify the size for this array to be j rows. That corresponds to the length of our unique players. So let's actually open that up again. Yeah, that's going to correspond to this length right here. And then we're using 3 functions together. So we have length, find, and isMember. So we are comparing kind of 2 columns here. So EV underscore 100T and then our unique players. So we are finding the amount of times that each player here shows up in our table and in this column in our table. And that will tell us the amount of times that they hit the ball over 110. And then again, we are specifying the size right there. So does that make sense or any questions on that? Okay. Alright, so now we got that, and then we are almost ready to plot. First, we're going to make another table. I could just probably add it to the table that we already made, but when I did this, I just made a table. So just for time, we're going to make a new table. So make a table for names and amounts. I'm just going to type this quickly so we can get to the end. Player. Okay. Alright, so let's look at this table that we just created right here. So here we have our unique player names, and then we have the amount that each player here hit the ball over 110. Okay, so now we are ready to plot. So the first thing I'm going to do is sort our table by the amount of times that they hit the ball over 110. So if I go to this table again, right now it's not sorted in any, well, it's sorted currently by alphabetical order by name, but I want to sort it by the amount of times that they hit the ball over 110. So let's do that. So we're going to use our sort rows function that you've probably been using a lot in the project. So I'm just going to rewrite our table basically. So players underscore t equals sort rows EV110 players underscore t. Then I'm going to sort this by the amount of times. And then I'm going to do it in descending order. There we go. And we'll go on a new line here. So on this line, I'm doing figure position. And when I put this argument for position, we then specify the size of our plot. So you don't have to do this, but you can do this just so the size of your plots are consistent throughout your project. So these first two values here, this is where your figure is going to show up in reference to the bottom left-hand corner of your screen. Now on my setup, it doesn't really matter because I have something called a window manager, so that part is irrelevant to me. But if you're on like Windows, if I put 00 and I run this, then your figure should show up in the bottom left. And then these last two numbers are the actual size of the plot. So I'm going to use a width of 850. I think it does it by pixels. And then 500. Okay, and then I'll do, we'll actually make our figure now. So bar, I'm going to make a bar chart. EV110 underscore players underscore T dot EV underscore 110 P underscore N. So I'm plotting the amount of times that they hit the ball over 110. Let's see, what did I do incorrectly? Oh. Line 44. Oh, spell position correctly. Alright, and then here is our graph. So it's not perfect yet, so we're going to go over how we can make this a bit better. And this will, again, be relevant to your project. So we're going to do x ticks, because as it currently stands, our tick marks, they're not very useful to us. They're spaced out too much, so let's fix that. I'll actually put this up here. Okay, so I'm going to do x ticks. And so I want to tick for each value that we have here. So I'm going to do x ticks 1, and then again I'm going to do length And then I'm going to do the length of basically the table that we made. So length of EV110 underscore players underscore t dot player. Now if I run this, then this is our new table. So we have a tick mark for each of our bars here. Okay, so let's actually open up our table. Oops, wrong one. Here. Nope, still not it. Player, this one. Okay, so in our code here for xticks, we chose the length by just getting the length of this column here. So I can, have a shorter line of code here, so I don't need to specify some column. Let's just do it for the table. So if I do length for a table, this should give us an error, and it does. It says undefined function length for our input arguments of type table. So we can't find the length of a table, but we can use something like the height, width, or size function. So instead I could do the height of our table, and then that's going to work. It'll give us the same kind of output that we had when we specified the length for just some column in our table. Okay, and then let's do xtick labels. I think there was a question on this last night in the Discord, so if you're still in here, this will help you out. So we can reference our table for our xtick labels, so we don't have to type out everything ourselves. So I'm going to do xtick labels EV110 players t.player. So doing this, I'm going to access that table that we have here, and I'm going to display each of these respective names. So if I run it, now we have all the names. Now, of course, this isn't displayed in a fashion that we like, so we're gonna change the angle. We'll do xtick angle of 30. Sure, we can run it. Okay, and now this looks a bit better. Let's also change our white ticks now. Because we don't need like 0.5 and 1.5, so let's change that. So I'm going to do white ticks from 0. I'm going to use the step size of 1. And then I'm going to do max EV underscore 110 underscore players underscore t dot dot EV 110 p underscore n. So this will make our white ticks formatted from 0 to 4. So it's going from 0, we're using a step size of 1, and then we're going to the maximum amount that a player hit the ball over 110 miles per hour. So here I actually don't need to, look at the limits. Well, I guess I did for 0, but I don't even need to look at the limits for our graph kind of visually to set my white tick max. So I can just specify the value itself from the table to set that limit. So imagine for your project, in this case, if the cases, they're increasing and increasing all the time, you don't need to look at the figure yourself. You can just specify, hey, put my white ticks from 0 to the maximum amount of cases, and then you can have that kind of formatted in an easier fashion, so you don't have to look at the figure manually to do it. So we're referencing again some variable. Okay, and then we're going to do title. So let's actually really quick, we have some time. I'm going to open up the deliverables that I updated. I updated some of the figures last night. So you'll see here that my graphs in the title, it shows up to November 1st of 2020. And it also shows top 5. So I didn't type in 5 and I didn't type in this state here. I had MATLAB draw from those numbers automatically. So let's show you how to do that right now. I'll go back over here. I'll do title. And I'll go over the formatting in just a second for why we have those the curly bracket and the bracket. So I'm going to type in players who had an exit velocity over. And here I'm going to put num to string. So this is converting a number to a string. And I'm going to reference our variable that we made before, which was called target exit velo. So that's going to convert this up here, this variable here, from a number to a string so it can be printed in our title. So num2 string. And then we have a space, and then miles per hour. And there's our bracket. I'm going to go on a new line here. Into in the 2020 MLB postseason. Let's first make sure it runs. Cool, it does. Okay, so let's go over the formatting here. Okay, this is just giving us a warning. But it still ran okay. Okay, so we have title. So my brackets here, you see on this first line, I have a left bracket here and then a right bracket over here. So because I have all of this wrapped in a bracket, that's going to put this on one line. And then you see down here, I have all of this also wrapped in brackets. And then that allows us to have that on a whole new line. Again, then these curly braces, I have to use those because I use this function here, num to string, so number to string. So I have to wrap my entire title in curly braces in order for this to run correctly, because you see that this isn't in quotes. So this is just a formatting kind of thing that you have to do if you use this kind of function right here. So you have to wrap those in curly braces. So if you run it, then you get this where I didn't type in 110 because I used num to string. It pulled that variable directly from MATLAB. Okay, so here's our plot. Now here's the big thing, kind of the big takeaway for helping with your project. So if I want to change this plot to, instead of doing 110 miles per hour, if I want to do it for 115 miles per hour, I can make it a whole new plot just by changing one number. So let's go up here, and I'm gonna just change this to 115. Now if I run this, and there we go, I have a whole new plot. I didn't type in anything besides just changing that one number. So we have players who had an exit velocity over 115 miles per hour in the postseason. So you see our title is updated to reference 115 miles per hour. And our plot was updated to only plot stuff for 115 miles per hour. And I didn't type in any of these names. So this is going to be a great method for the project if you haven't implemented your code, kind of like this. So I'd recommend doing this. It would save you a lot of time. Okay, so I guess we didn't go over for loops in quite as much depth as I would have liked. So we're going to go over for loops in more depth next class. But hopefully this kind of added context to why you would use a for loop sometimes. So you don't have to calculate all this stuff manually, you just did it for us in this for loop right here. And hopefully all these other formatting things will help you to kind of automate your code for the project as well. Okay, so we're out of time now, went right up to the end. So I'll see you guys on Wednesday. If you have any questions on the project, go to office hours at 12 today, or go on the Discord. Alright, so I'll see all of you on Wednesday.
Thank you, Professor. And Professor, quick question. What was the quiz going to be on Wednesday?
The quiz will be on the if statement. So if else if and else.
Okay, thank you.
Mm-hmm.